Are we on the verge of witnessing a supernova light up our sky? When the massive star Betelgeuse eventually explodes, it will shine as bright as the full moon, possibly even visible during the day. A while back, this stellar giant puzzled scientists with unusual shifts in brightness, sparking widespread curiosity. But now, researchers believe they've uncovered the truth behind the mystery. So, is Betelgeuse about to go supernova? Stick around to discover the full story behind this fascinating cosmic event. To us, the sun often feels like the ultimate force in the cosmos, and for good reason. After all, you could fit Earth inside our blazing source of light and heat about 1.3 million times. With a diameter nearing 1.4 million kilometers, the sun is undeniably massive. But even our mighty star pales in comparison to some of the true giants in the universe. Take Betelgeuse, for example. This colossal red supergiant, located roughly 650 light-years away in the Orion constellation, dwarfs the sun in every possible way. Its diameter is about 800 times greater, and it shines up to 10,000 times brighter in visible light. Or at least, it should. Back in 2019 and 2020, the shoulder star of Orion, Betelgeuse, began acting in a way that left astronomers stunned. In a matter of weeks, its brightness dropped significantly. To make sense of this puzzling event, it helps to understand how a star's brightness is measured. Astronomers use a scale called magnitude, or mag, which doesn't account for a star's distance, just how bright it appears from Earth. On this scale, lower numbers mean a brighter star. Betelgeuse typically shines at around 0.3 to 0.4 mag, but 5 years ago, it suddenly dimmed to 1.289 mag. The drop in brightness was so extreme, it was visible to the naked eye. Once among the brightest stars in the night sky, Betelgeuse plunged to 21st place in terms of apparent brightness. Betelgeuse is known for its periodic fluctuations in brightness, so changes in its luminosity aren't uncommon. However, this time, the star dimmed much more rapidly and dramatically than usual. This unexpected behavior prompted astronomers to search for explanations, and one of the most striking theories suggests that Betelgeuse might be on the verge of exploding. So, is Betelgeuse about to go supernova? And why do scientists link this sudden dimming to such a cataclysmic event? For one, Betelgeuse is a red supergiant, a type of star that's already in the final stages of its life cycle, destined to end in a massive explosion. Additionally, a star nearing its end can exhibit signs like significant expansion and a drop in brightness, both of which can precede a supernova. But here's where things get complicated. The truth is, astronomers have never caught a star in the act of going supernova. We've never observed one just before it explodes. That's why we can't say for certain whether a star will dim years, days, or just hours before the end. What we do know is that Betelgeuse hasn't exited the cosmic stage just yet, because if it had, we'd definitely know. Even when it's not making headlines by mysteriously dimming, this stellar giant already shines about 10,000 times brighter than our sun. But once it goes supernova, scientists predict its brightness could jump by a factor of 16,000. That would give Betelgeuse an apparent magnitude between -9.5 and -10.5, making it as bright as the full moon for weeks, and even visible during the day. At that point, the dying star would outshine everything nearby, easily becoming the brightest and closest supernova ever recorded. So, if the dramatic dimming we saw 5 years ago wasn't the sign of an imminent explosion, what caused it? The answer: dust. Later observations from the Hubble Space Telescope revealed that a massive eruption of plasma expelled a huge dust cloud, which temporarily obscured the star and caused it to appear nearly 2/3 dimmer. While Betelgeuse, being an aging star, routinely sheds vast amounts of stellar material, this particular event stood out for its intensity. A mix of vigorous convection and expansion likely triggered an exceptionally powerful plasma eruption, estimated to be 2 to 3 times stronger than usual. This led to a mass ejection roughly 30 million times greater than the Sun's. Afterward, Betelgeuse briefly returned to its normal brightness, only to shine significantly brighter than usual, before dimming again just a few months ago. Although this drop in brightness wasn't as dramatic as the dimming seen in 2019 and 2020, astronomers still recorded the star's lowest luminosity in 2 years. So, is this the beginning of a supernova? The honest, if somewhat frustrating, answer is, we just don't know. No astronomer can say with confidence whether Betelgeuse will explode tomorrow or remain stable for another million years. Strictly speaking, it's entirely possible that the massive star has already met its spectacular end, and we're simply still waiting for the light from that final explosion to reach us. But is Betelgeuse truly alone in this fate? A 2023 study suggests the star could go supernova much sooner than previously believed. Researchers at Tohoku University in Sendai, Japan, closely analyzed Betelgeuse's pulsations and discovered several intriguing clues indicating the star is significantly older than once thought. As the red supergiant's outer layers pulsate, they produce fairly regular variations in brightness, with 2 dominant cycles lasting about 2,200 and 420 days. Astronomers generally interpret the shorter cycle as the star's heartbeat. However, if the longer 2,200-day cycle is actually the true heartbeat, it could mean that Betelgeuse is even larger than we imagined. What is now about 800 times the diameter of the Sun would actually be 1,200 times larger than our host star. This also suggests that Betelgeuse is further along in its life cycle and is closer to becoming a supernova. Japanese researchers used computer simulations to track how stars evolve from their birth to their final stages, identifying when they begin to pulsate. The key finding is that all the pulses observed from Betelgeuse correspond to a much later phase than previously thought. Based on this, a core collapse, and consequently a supernova explosion, is expected within a few decades after the carbon in its core runs out. Unfortunately, pinpointing the exact timing of the star's demise remains difficult. Scientists estimate that carbon depletion could occur within a few hundred years. This timeline is much sooner than earlier predictions that placed Betelgeuse's supernova event at around 100,000 years from now. However, it's worth noting that the Japanese study has met with mixed reactions. Astrophysicist Morgan McLeod, for instance, points out that the data doesn't align with other analyses of the star. Specifically, if the 2,200-day cycle were taken as the star's primary rhythm, Betelgeuse would appear excessively large, which raises doubts about these new findings. Moreover, recent studies challenge the notion that Betelgeuse moves through space alone. In fact, the latest research suggests this massive celestial body is accompanied by a companion star. Once again, it was the longer 2,200-day cycle that provided a crucial clue. A recent re-examination by a team from the Flatiron Institute in New York uncovered several surprising irregularities, including the fact that the 2,200-day cycle in the star's light curve follows a different pattern than the more subtle 400-day pulsations. However, the researchers were unable to link these variations to known causes like convection currents, rotation, or magnetic field effects. In the end, only one plausible explanation remained for the long-term fluctuations: the presence of a smaller companion star. Its orbit would naturally correspond to the observed brightness variations over time. When the companion star moves behind Betelgeuse from our viewpoint, the brightness dips to its lowest point. Conversely, when the companion is positioned next to Betelgeuse, their combined light causes the brightness to peak. Additionally, the companion star might act as a dust pusher, affecting the distribution of surrounding dust clouds and contributing further to Betelgeuse's changing brightness. But why did this companion star go unnoticed for so long? Astronomers believe it's due to its relatively low mass. Calculations estimate it to be about 1.7 times the mass of the Sun, roughly 12 times lighter than its much larger partner. Despite this, the companion likely orbits very close to Betelgeuse, at a distance just 2.43 times Betelgeuse's radius. Because of this proximity, the companion is overshadowed by Betelgeuse's brilliance, and its own brightness changes and pulsations make it even harder to detect.